In today's lesson, we're going to examine the idea of mutually exclusive events. In lots of situations, there's the idea that something can't happen at the same time. Okay? For example, if we roll a dice and you want an even number or an odd number. Well, those things aren't possible at the same time. Okay? So if they aren't possible at the same time, we consider those things mutually exclusive. Okay? If you were to draw a Venn diagram, you'd have your even numbers or your odd numbers, but they don't overlap. They can't happen at the same time. Other situations can happen at the same time. Okay? We would call those non-mutually exclusive events. So for example, I roll a dice again, I want even numbers or I want numbers bigger than 4. Well, the number 6 is both even and bigger than 4. So I have something that could happen at the same time. What we need to think about in these situations, this idea of mutually exclusive, is how do I figure out the different possibilities? So what we need to think about here is if I want the probability of something, I need to think about the word or, A or B. And the easiest way to do it is simply add the two different things together. In the ways A can happen, the ways B can happen, add them together. And this is true as long as they don't overlap, as long as they are mutually exclusive. So we'll take a look at an example here. We have a bag of marbles. It contains 3 red, 4 green, 5 black. What's the probability of pulling a red or a green from the bag? So I'm going to write this down as the probability of red or green. The question I need to ask myself is this mutually exclusive? Is it possible to have both of those things happening at the same time? Well, it's not possible to get a red that is green at the same time. It's either red or it's green. So I can simply figure out the probability of red ones and add that to the probability of green ones. They're two distinct separate things. So red, how many reds are there? There's 3. Out of, how many altogether in the bag? 12. Green, there's 4 of those out of the 12. So if I combine them, there's 7 out of 12 ways of getting a red or a green. Okay, that's a mutually exclusive thing. If things are not mutually exclusive, and this is kind of more what we want to do in this course, then there is an overlap. It's possible that those two things happen at once. Okay, so we talked about the dice. Let's talk about cards for a second. If I had a deck of cards and I said I want to get a red card or a face card, well, some red cards are face cards, so there's an overlap. And the problem is if I do them two separate things, if I just try to figure out the first group and then add to the second group, is I've counted some things twice. They were counted as red cards, but they're also counted as face cards. So what I need to do is subtract the overlap, the end, the red cards that are face cards. Okay? Because there's this overlap, a Venn diagram is often a very helpful tool for solving this. So let's try an example just to get an idea of what this non-mutually exclusive thing looks like. So find the probability of turning up an even number or a number greater than 3 when rolling a die. So now I want probability of an even number or a number greater than 3. So I see the word or, it means I can just add these things together. Unless there's an overlap. Is it possible that something is even and greater than 3? Well, sure it is. Number 4 is both even and greater than 3. So I need to subtract the things that are both even and greater. So let's give this a try. How many even numbers are there? 2, 4, 6. So 3 of the 6. How many things greater than 3? Well, the numbers 4, 5, and 6. 3 out of 6. How many things are both even and greater than 3? The number 4 and 6. So the answer to this one, if I add them all up, 3 plus 3 minus 2 gives me 4 out of 6. Okay, now I did that without a Venn diagram, but I could have done it with the Venn diagram. So we'll take a look at that example in the Venn diagram format. Okay, here's my dice, my universal set. Here's the things that are even. Here's the things that are greater than 3. What digits fit into the overlap? Well, the number 4 and 6. So there are 2 digits that fit in there. How many things are just even? Well, there's 3 that should be in this circle, right? I've got 2 in the overlap, so I've got 1 left that's just even, the number 2. How many things are greater than 3? Again, I've got 3 things in there, but I've got 2 in the overlap, so I'm left with 1. And I know my box has to add up to 6, or 6 things altogether, so there's 2 things left over in the box. So if I want to do probability of E or G, it means it could show up in the E circle, or the G circle, or the overlap. In other words, if I add up this, that's E or G. There's 1, 2, 3, 4 things there, right? 1 plus 2 plus 1 out of the 6 things in the box. So it's kind of your choice, and we'll look at different situations if you want to use just the formula or if you like the Venn diagram thing. Okay, the Venn diagram takes care of this subtracting, the overlap. That's the whole idea of how we work with the Venn diagram. And we'll try another example here. 28% of the population of Statsville wears contact lenses. 37% have blue eyes, and 9% are blue-eyed people who wear contact lenses. Is wearing glasses mutually exclusive of having contacts? Contacts, right? In other words, is there an overlap? Well, up here it says there's 9% who are blue-eyed and wear contacts. So no, it's possible to have blue eyes and contacts. So if it's possible to both, they're non-mutually exclusive. There is an overlap. Part B, what is the probability that a randomly selected person has blue eyes or contacts? So blue eyes or contacts. So this time, let's try the Venn diagram method first. So take our universal set. Our universal set is Statsville. We got some blue-eyed people. We got some contact-wearing people. We have some people who are both. In fact, we have 9%. So I'm going to use this as my percents this time, okay? 9% who do both. How many people have blue eyes? Well, it says 37% have blue eyes. So this circle is supposed to be 37. But I've already got 9 people who have both. So my overlap, got to get rid of that. How about contacts? Contacts is supposed to be 28. But again, I got 9 people who have both. So I've got 19 left over. I've got left in the circle here, I got 44. Not that you need to know that for this question, but that's what it is. So how many people wear blue eyes or contacts? In other words, how many people are in the circle altogether? So 28 plus 9 plus 19 is 37, 47, 56%. Okay. Now, if you don't like Venn diagrams, the other way we could have done that, blue eyes or contacts. Let's figure out the blue-eyed people, the contact people, and the people who have both. I got to subtract that because they got counted twice. So blue-eyed people, back to the question again. 37. Contact people, 28. People who have both, 9. 37 plus 28 minus 9, 56%. So 2 different ways of approaching the same question, formulas or Venn diagrams. Okay, you guys try one. So pause the video, give it a try, see if you can figure it out. You can use the formula or the Venn diagram method, your choice. A group of 45 students, 28 have dark hair, 19 are taller than 185 centimeters, and 5 are neither dark-haired or taller than 185. Okay, a student selected at random. Determine the probability that the student is... Well, I look at this and I say to myself that there's an overlap. There's people who are tall and have dark hair. So I'm going to use the Venn diagram. I like the Venn diagram. I think it's pretty easy to work with once I get the hang of this. So what do I need? I need dark-haired people and tall people. And what have they told us? 45 students, 28 have dark hair, 19 are tall, and 5 are neither dark hair or tall. In other words, there's 5 people out here. So they've kind of given us the opposite information we're used to. We're used to being given the overlap, the people who are tall and have dark hair, but they've given us a complement to that. Okay, so I got to fill in the rest of this Venn diagram. What do I know? I know that the box has 45 people in it, but I've already put 5 in here. So in other words, the rest of this, including the overlap, can only equal 40. Well, if 28 have dark hair and 19 are taller than 185, 28 plus 19 gives me 47. But I know there's only 40 in there. What does that tell me? It tells me there's an overlap. How much? Well, the difference between 47 and 40. In other words, 7. Once I've got that figured out, I can do my 28 minus 7 is 21 dark-haired people. 19 minus 7 is 12 tall people. And now I got my Venn diagram done. I'm ready to answer my questions. What's the probability of being taller and having dark hair? In other words, what's the overlap? Well, 7 of the 45 people. How about taller or has dark hair? So that could be anywhere in those circles. So I've got the 21 plus the 7 plus the 12 out of 45. In other words, I got 28, 38, 40 out of 45. I also could have done that one using the complement, right? Get rid of what I don't want. And the last one, not taller than 185. So taller, not taller. So where are those in the diagram? The people who are not taller than 185. Well, everybody inside this circle is taller than 185. So everybody not in that circle, in other words, these people, are not taller than 185. And together that makes a total of 26 out of 45. Yeah, those Venn diagrams come in really handy when you have that situation of overlaps. And last one. What are the odds against a 5-minute segment chosen at random from a movie containing either violence or humor? Yeah, so even before I read the rest of the question, I'm thinking to myself, I got to worry about odds, which is something we did yesterday, so I need to think about probabilities. And I see the word or, so I'm thinking about overlaps. Is it possible? Yeah, keep reading. If it's known that violent scenes occur 40% of the time, humorous scenes occur 30% of the time, and 10% of the scenes contain both. In other words, there's an overlap. So I need to figure out the probability of violence or humor. I'm going to try this one with the formula, okay? Let's see if I can do that one pretty quickly. So I need the two separate things and minus any overlap. Well, violence, 40%, okay? These are percents. Humor, 30%. Overlap, 10%. So 40 plus 30 minus 10, that gives me 60%. That's the probability of this happening. But I wasn't asked for probability of it happening. I was asked for odds of it, and in particular, the odds against. So if you go back to what we did yesterday, odds against, or the probability that it doesn't happen compared to the probability that it does happen. We just figured out the probability that it does happen. That was 60%. So what's the probability it doesn't happen? Well, that's got to be 40%. And if we reduce that, we can say 2 to 3. Okay. Now, I use a formula. If you wanted to use a Venn diagram, that is totally possible. Our Venn diagram would have violence, humor. We had 10% in the middle. Violence was 40. So this circle is 40. If I subtract the 10 already. Humor was 30. If I subtract the 10 in the overlap, I got 20. So if I'm talking about or, add them all up, and that should come out to 60%. And it does. Okay, so that's our idea for today. Mutually exclusive. Can they happen at the same time or not? Now, notice we spent most of our time dealing with non-mutually exclusive, things that have an overlap, because they're slightly more complicated. If they don't have an overlap, just add them up, the two different situations. And that's all you have to do. Okay, homework, give it a try. If you're stuck, come see me. We'll figure some things out, and we'll go from there.